Find the first partial derivatives for each function. In our first example, sorry about that if that glitched on you, we have a two variable function, 7 minus x squared minus 7y squared, which is found in one of the previous videos that we did. In that example, we plug various numbers in. In this video, we're going to be more interested in the behavior of a function in a particular direction, in the x direction or the y direction. So we're going to take what's called a first partial derivative. The derivative of a constant is 0. The derivative, in this case, we're going to focus on x terms. We have an x term, its derivative is negative 2x. The third term does not have an x, so it's considered a constant, and we don't have to write the zeros. Look for your x terms. Now, when your subscript becomes y, you focus on terms with a y variable to take the derivative. No y, so that's derivative of 0. No y, that second term is a derivative of 0. Third term does have y, and its derivative would be negative 14y. In our second example, we have a two variable function, g of xy equals natural log of x cubed plus y squared. Now remember, the derivative of natural log is 1 over the terms that follow times the derivative of the terms that follow. So when we take a first partial derivative with respect to x, we're going to go ahead and write the reciprocal, 1 over x cubed plus y squared. But the derivative only with respect to x will be 3x squared. The y term has no x attached, so it's considered a constant, and its derivative is 0. Now when you switch over and your subscript is y, you're still going to do 1 over x cubed plus y squared, but this time you're only going to take derivatives with respect to the y variable. X cubed has no y, so its derivative is 0. Y squared does have a y, its derivative is 2y. And here in purple, I reminded you of the derivative of a natural log function. So whatever follows natural log, it's the derivative of that over the original. You have to be careful in the numerator with partial derivatives to only take the derivative of the variable that you're focusing on. Third example, we have z defined as x squared minus 7xy plus y squared. These lowercase deltas, that's the derivative of function z with respect to variable x. These are also written z sub x. Starting with your first term, that does have an x, so its derivative is 2x. The middle term has an x. What's the derivative of just x? It's 1 times negative 7y gives you negative 7y. The third term has no x, so its derivative is 0. Then we take the partial derivative of function z with respect to y, z sub y. Our first term has no y, derivative of 0. The middle term has a y. The derivative of y is 1 times negative 7x is negative 7x. And the third term has a y. Its derivative is 2y. Find the first partial derivatives and evaluate at the given point. This time we not only have a partial derivative, but we have numerical values to substitute in once we've done that. Starting with derivative with respect to x, we start with our first term. That derivative is 4x cubed. The derivative of x is 1 times negative 3y is negative 3y. Third term has no x, its derivative is 0. Now, that partial derivative with 2 subbed in for x, negative 2 subbed in for y, that's 4 times 2 cubed minus 3 times negative 2. 2 cubed is 8 times 4 is 32 plus 6. That gives us a grand total of 38. Now going back to our function, x to the fourth has no y, so that derivative is 0. The middle term, the derivative of y is 1 times negative 3x is negative 3x. The third term has a y. Its derivative is 4y cubed. Substituting 3 into the x and 0 into the y, that gives us negative 3 times 3 plus 4 times 0 cubed. 0 cubed is 0 times 4, still 0. Negative 3 times 3 is negative 9. In our next example, we have three variables in function w. We have x, y, z. It's not in every term, but those three variables are present. Taking the derivative with respect to x, we have 5x to the fourth times yz to the fourth plus 1 times y, that's y. The third term has no x, so there's no derivative to take. This is considered a constant, and it has a 0 derivative. Going back through with respect to y, our first term, the derivative of a single y is 1 times x to the fifth z to the fourth. That's x to the fifth z to the fourth. The middle term, our derivative of y is 1 times x. That's x. Our third term also has a y. The derivative of y is 1 times negative 4z is negative 4z. Finally, taking the derivative with respect to z, our first term, the z term has a derivative of 4z cubed times x to the fifth y, x to the fifth y. The middle term has no z, its derivative is 0. There's nothing to write. Back in our third term, the derivative of z is 1 times negative 4y is negative 4y. Now, we're going to take those partial derivatives and substitute in numerical values. As a courtesy, these were the three partial derivatives we took on the previous slide. I just wrote these here for convenience. Let's find w sub x, that's the derivative of function w with respect to x, with these three values plugged in for x, y, z respectively. The top right derivative is the one we need to look at. Replace x with 2, y with 5, z with negative 4. So that's 5 times 2 to the fourth times 5 times negative 4 to the fourth, and then plus your y value, that's plus 5. Carefully place this in your calculator. You get a really large number of 102,405. Moving to the second evaluation, we're asked to find the derivative with respect to y with these same three numbers plugged in. Now let's go to this second line at the top right of your screen. That's our derivative with respect to y. Replace x with 2, z with negative 4, and we don't have any y's left over, so we actually don't have to plug a 5 in anywhere, because in this derivative there's no y's that can receive that 5. And that's okay, they don't always have to be that way. X to the fifth, that's 2 to the fifth. Z to the fourth, that's negative 4 to the fourth. Plus x, that's plus 2. Minus 4z, that's minus 4 times negative 4. Carefully place these into your calculator. You should get 8,210. Finally, the derivative with respect to z, it's this last partial derivative at the top right of your screen. Same three numbers. We're going to plug a 2 in for x, 5 in for y, negative 4 in for z. Carefully do that all the way through, and you should get negative 40,980.